Thank you for having me here today. I'm going to talk about pre-harvest conditions impact staccato quality. So what impacts staccato quality? Leaf calcium content, leaf size, canopy temperature, relative humidity, and orchard management have all been implicated in impacting staccato quality. And I'll talk about this more through the presentation. We collected our data over 3 growing seasons, the 2015, 16, and 17 growing seasons. And our data was collected from 6 commercial orchards. 2 are located in Oliver, 2 are located in Penticton, and 2 in Summerland. And we collected leaves and fruitlets being pre-harvest or premature cherries at 2 to 3 weeks pre-harvest. And we assessed the mineral content in these leaves and fruitlets that were collected at pre-harvest. We also collected commercially mature cherries at harvest, and we assessed the quality of these commercially mature cherries at harvest and upon longer term storage. And the overall goal or aim of this work was to examine any relationships between pre-harvest mineral status in these leaves and fruitlets with orchard growing factors and mature cherry fruit quality. We stored our cherries in 10 kilogram capacity cardboard boxes with polyethylene liners. The cherries were stored for 4 weeks at 0.5 degrees Celsius. And again, we assessed the quality of the cherries at harvest and after longer term storage, this 4-week storage period. This work targeted looking at the relationship between pre-harvest factors and 2 storage disorders, pebbling and pitting. Pebbling is a storage disorder that's described as a rough or uneven surface. It's also termed alligator skin, and it can rank from none, slight to severe. Pitting is another storage disorder. It's characterized by 1 or more indentations in the cherry fruit, and it can rank from none, slight, moderate to severe. Less pebbling and pitting was observed in the mature stored cherry fruit when pre-harvest leaves had higher levels of calcium. So mature cherries coming off of trees that had pre-harvest leaves with higher levels of calcium showed less pebbling and pitting upon storage. The leaf calcium range measured was around 1.39 to 2.25%, and the average was 1.7% leaf calcium. Again, we assessed the mineral content of leaves and fruitlets that were collected 2 to 3 weeks pre-harvest, and we assessed the calcium, magnesium, potassium, phosphorus, boron, zinc, iron, manganese, copper, and nitrogen contents. And although less pebbling and pitting was observed in mature stored cherry fruit when pre-harvest leaves had higher levels of calcium, there was no direct relationship observed between fruitlet calcium levels and pebbling and pitting disorders. We also saw higher levels of phosphorus in leaves, and fruitlets were associated with cherry fruitlets and mature cherry fruit with higher levels of dry matter and larger leaves on the trees. This information is important in light of the work done by Peter Toivonen that links higher dry matter levels in cherry fruit with better cherry fruit quality and better cherry fruit quality retention. We also saw less pebbling and pitting in the mature stored cherry fruit when pre-harvest leaf size was larger. So mature cherries coming off of trees with larger leaves showed less pebbling and pitting upon storage. We also saw larger leaf sizes were linked with lower growing or canopy temperatures, and cherries coming off of trees with larger leaves had higher levels of dry matter at all growing stages, that meaning the fruitlet and the mature fruit stage. So again, this information is important in light of the work that Peter Toivonen's done, linking higher levels of dry matter in cherry fruit with better cherry fruit quality and better cherry fruit quality retention. We assess leaf size, leaf area index, canopy span, and tree density. I want to talk a little bit about leaf area index. Leaf area index is really a measure of the light penetration into the canopy. On the left-hand side of the slide, there's a photograph that was taken with hemispherical photography. And it basically, you can use a computer program and some equations to back out a quantitative number of leaf area index from a photograph. That's not really the point. I just want to point out that leaf area index, what it is, and that it's important because again, leaf area index is a measure of the light penetration into the canopy. High leaf area index, less light penetration into the canopy. Low leaf area index number, higher light penetration into the canopy. That's characteristic of a more open pruned canopy. And we found a negative relationship between leaf size and leaf area index, meaning higher leaf area index, less light penetration, smaller leaves. lower leaf area index, more light penetration, more of an open prune canopy, larger leaves. And this larger leaf is important in the relationship. We saw that cherries coming off of trees with larger leaves showed less pebbling and pitting upon storage, and also showed higher dry matter levels, which is of relevance for fruit quality. We also saw less pebbling and pitting observed in mature stored cherry fruit when the orchard canopy was cooler. So cherry growth associated with higher temperatures showed mature stored cherries with more pebbling and pitting. The average temperature we assessed over all growing seasons and all orchards was around 20.4 degrees Celsius, and the average high temperature or daytime temperature over all growing seasons in orchard was around 32.9 degrees Celsius. And so microclimates or differences in local orchard environments seem to be implicated in pebbling and pitting disorders. Notably, we saw an increase in decay in stored cherries that came out of canopies with lower average temperature. So it's a complex situation, it's a balance. And the average decay level or incident we saw in the mature stored cherries was over all growing seasons in all orchards, on average was 2%. Just for knowledge, we placed our data loggers in 6 orchards. The average temperature range over all seasons was 19.6 to 21.1 degrees Celsius. The average high temperature range or daytime temperature range was 31.1 to 34.8 degrees Celsius, and the average lower overnight temperature range was around 5.7 to 10.7 degrees Celsius. We also saw less pebbling and pitting in mature stored cherries when the relative humidity environment or canopy environment was higher. The relative humidity range measured was around 49.6 to 65.3%, and the average relative humidity was around 57%. So again, these microclimates are differences in local orchard environments are implicated in these pebbling and pitting disorders. And we also saw a relationship with cherries coming out of higher relative humidity canopy environments showed higher dry matter. And again, this is important in light of the work done by Peter Toivonen in linking higher dry matter levels in cherry fruit with better cherry fruit quality and better cherry fruit quality retention. And also we did see that relationship with cherries coming out of higher relative humidity canopy environment showing more decay upon storage. So it is a complex system. And also I just repeat that the level of incidence of decay we saw in the cherry fruit was around 2% on average. So what is the science behind these effects? Well, larger leaf size, lower canopy temperature, and high relative humidity are really pointing to the transpiration capacity of the cherry trees. Calcium, zinc, and potassium are essential elements for growth, and highly transpiring leaves are known to accumulate elements such as calcium. Highly transpiring leaves are known to accumulate calcium. So we hypothesize that it's the transpiration capacity of the leaves that likely contributed to the lower ambient temperature in the tree canopy via evaporative cooling and providing a higher relative humidity environment in the tree canopy. Mineral nutrition may contribute also, so good calcium application may be of benefit. I do have a point here in blue noting environmental differences due to different orchard locations may have also contributed to the differences in temperature and relative humidity. What I mean by this is this work was survey work in nature. We collected our data up and down the valley from those 6 orchards from Oliver up to Summerland, and we assessed the data with statistics to see what variables might be important. It wasn't a rigorously designed experiments where we had one plot in one location with multiple trees on that one plot and the trees receiving different treatments. This was survey work. But based on the data and based on the fact that highly transpiring leaves do accumulate calcium, and the fact that transpiration is a gradient driven process, meaning that transpiration is going to proceed better in a higher temperature, lower relative humidity environment. So based on the data we see, we hypothesize that it's the transpiration capacity of the leaves giving off more water, leading to evaporative cooling, which is giving that lower canopy temperature and higher relative humidity in the canopy versus the differences in actual physical location of the trees throughout the valley. So how can you reduce pebbling and pitting in the orchard? Well, through orchard management, you want to prune for a more open canopy structure by early fruit development, as this increases early season light penetration and leaf size. Because remember how I harped about leaf area index, higher leaf area index, less light penetration, smaller leaves. Lower leaf area index, more light penetration, more of an open prune, larger leaves. Larger leaves are good. Larger leaves increases transpiration. It's linked to increased dry matter in the cherry fruit, which is important for quality. It increases calcium in leaves. So again, calcium application may help also. You just want to recognize the importance of orchard management in creating an optimal environment to promote optimal fruit quality. So the main take-home message from this work, leaf and fruitlet mineral content cannot be looked at in isolation in the context of understanding sweet cherry quality. Growing conditions impact fruit quality. Associations between mineral content and disorders are not necessarily solid proof that the mineral is the main factor in the cause. Leaf size, canopy temperature, relative humidity, and leaf calcium were identified as important variables and may provide direction for experimental design in future field studies. Because again, this work was survey in nature. We went up and down the valley, we collected data, we used statistics to analyze the data and see what variables were important. It wasn't a rigorously designed experiment, again, where we had a plot that received different treatments, because those types of field work experiments are expensive. So we wanted to do this survey work to examine what variables might be important that can be plugged in to future field studies. So this leads to the purple point. Future research or further research is needed to fine-tune specific pre-harvest recommendations to optimize cherry post-harvest quality. So this work has recently been accepted for publication as a short communication in the Canadian Journal of Plant Science. I just did the proofs on Monday, and it is available as a just-in communication on the Canadian Journal of Plant Science's website if you want to learn more. If you want to learn more about the analysis we did, we used principal component analysis to identify the key relationships in our multivariate data. So I want to end with an acknowledgement slide. We are grateful for the BC cherry growers who kindly allowed us onto their property for our experimental work. The cherry growers let us onto their land when they were busy earning their livelihood. It was a very busy and stressful time for them, and they accommodated us in this research. So we're very grateful to those BC cherry growers, because without them, we wouldn't have been able to collect this data and generate this knowledge. So we're very grateful to those BC cherry growers. We also acknowledge Victoria Lay, Madeline Brooks, Julia Wu, Karsten Burton, and Danielle Ediger for their technical assistance. These cherry projects are really very labor intensive, and they require a lot of people power. So we're very grateful to the technical assistance that we had. And we are also grateful to Lindsay Hainstock, Charlotte Laming, Angela Wilson, and Bill Walk of the BC Tree Fruits for their help in orchard identification and expertise in the tree fruit industry. They hooked us up with the orchardists, and they helped us out. So we're very grateful to them. So on that note, I will thank you for your time and attention, and I will end this presentation, and I look forward to answering your questions to the best of my ability. And so I look forward to answering your questions. So thank you for your time and attention.